Hello and welcome to the channel. The topic today is Microsoft Foundry Local CLI and PowerShell. So, what is Microsoft Foundry Local? This is an SDK, but it's also a CLI that can run open weight models on your own device. And what is an open weight models? It's mostly an open source models that can help you to limit your token consumption that will run on your device, on your computer, your infrastructure, so it can help also to protect your privacy. These models also can be used on workflow because not every workflow need a frontier model. And open source models, mainly the Chinese one, are getting better and better. So it's a really good option for some tasks in AI. So today we'll work mostly with Foundry Local CLI. It's a very lightweight CLI that run on macOS X and on Windows. And it comes with a curated list of models that pair with your device, NPU, GPU, or CPU, and their acceleration. So for the first demo, we will use the Foundry Local CLI, and the Foundry Local CLI comes with an OpenAI API that is local, and you can get the server configuration here. So here you have the URI and you see that is ready. So let's start. You have the code here. So I have the REST API URI in the variables. And I create body variables with the models. I choose Microsoft V4 Mini because it's very light and for this demonstration is enough. And I have an array of hash maps where I have a role, which is user, and the content, which is my prompt. And the prompt today will be give the name of the capital of Belgium. Then I put all in the parameters, so with the method post, the URI, with the URI that I want a chat completion, the body converted to JSON, and the content type that is application JSON. So let's try. Oh, sorry. This thing happened when we switch between Mac and Windows. So now we get the result and we can get the content of the result. So yes, the capital of Belgium is Brussels, no problems. What is important also is to see that the result, so we have several properties. We have the models, we have the choice, which is the response from the AI. What is important with the choice to understand is that I will put the choice is an array. Generally, we take a look at the first item, the item with the index 0. And here you still have the same hash map with the role assistant. Assistant is the role that take the models when he reply to you. Also important to have the usage, and you see that my prompt, what is the capital of Belgium's, count for 11 token, and the completion is count for 7 token. It's very important to remember from this point is that every models in Foundry Local has a context limit. So be aware of that. That's the sample chat that you can have with Foundry Local. The first demo was pretty basic. It was a simple chat. But with the OpenAI API, you know that you can have multiple roles. We have seen the role user that contain the user prompt, but we have also the role systems that contain a prompt that will define how the model will behave and that will put some limit. This is where in a message I put a new hash map with systems. So here we try to make the models to create a PowerShell command. So the content of the system will be your PowerShell creating assistant. Only give code when requested. So let's give a try. Okay, let's see the number of tokens that have been used for this request. A little more, and let's see what the models give us. That's a basic script, but I think it could work. Until now, we just have one interaction with the model. And it means that every time we will ask the model to do something, it will have no memory of what have been done before. So we need to create some kind of memory to remind the models what have been done before. And for that, we cannot simply use an PowerShell array. We need to have a more efficient collection, more efficient list that should be ordered because we need to add the system, the user, and we will see we need to add the assistant response and the new prompt. That's why here we will use system collection generic hash table for our messages with several hash tables. So the one systems and system will tell us you are a science popular research specialist in physics. And we will ask a question. Explain quantum computing in plain English in less than 200 words, which is really optimistic. We still use the same models, still everything. So let's try it. Until now, it's pretty basic. We already do that. The only difference is that instead of having an array, we have generic list. But for JSON, it doesn't matter. Okay, I will put the assistant response into a variable. Let's see how many tokens we use. So clear amount. Sorry. And now what we will do is that we will put the assistant response into our message, the one that will be sent to the models again, and we will create a new prompt. Now explain it to a 5 years old. We can see the messages, variables. So you see that it's ordered. You have the system, the first prompt, the assistant response, now the second prompt. Let's try it. And you see that I didn't mention quantum computing in the second prompt. Just now explain it. So the model should remind what is it. Oh, let's see first how many tokens were used for this request. So a little more, and let's see the result. So, okay, imagine you have a super special tool that can do a lot of things at once. So yes, it looks like something for 5 years old. Now that we have seen memory how to add the previous assistant response to another prompt, we can see how we can use tools in a model. Um, the AI models doesn't execute anything. They don't have the possibility to do that. Instead, they will reply for and ask to execute a tool, which is a command to the programming language that coded them. So first, you need to define a tool. It's a JSON. So you need to define what is the tool, the type, and what is the function, and what are the parameters. This is what I would define a tool. So here I have defined a tool that we call a PowerShell function that is called uh, get VNet pairing status. And I define a function here in my script. So this function is a fake function because the goal is not to explain how to query peering in VNet. So we will always reply and send a response with the pairing status connected. So we have a definition of the tools, and we are messages, which is still generic list. And here I will say that you are an infrastructure assistant. You have access to tools that carry live as your state. When a user asks about the status of a resource, call the appropriate tool instead of guessing. Only answer from tool result, never fabricate resource state. And here I am my prompt is the VNet, is the up VNet in the RJ network prod period correctly. So that's the things. And in our body, I will have the tool choice. I can have all the tools that I want, and I can also um, uh, ask the models to, I can force the model to use my function, which is get VNet pairing status. But I can say, oh, use the function you want, use the tool you want, or limit the tools. And you can see here it's an array. And then we need to do to get the result the same as we did before. So let's try. Oh, okay, let's take a look at the result choice, and we will see something a little different than what we've seen before, because here we will have a content from the assistant that is tool calls. And what we will have is get VNet pairing status with parameters, VNet hubs, and other things. let's put it into a variable. Now I will do something a little more complex. So I will try to see here. I will show you the member of this object, and I will try to get the finish result. As you see, instead of the message is tool call, the message. Oh, sorry. I need to do the content. Yes. The tool call. Yes, you have the things. So here I will ask if there is the finish based on the tool call. That's what we have. Then what we'll do is to add the role assistant with control the messages. And for each, because this is an array, for each tool call, I will collect the arguments, convert from JSON, and I will, for the call, I will query my function. And if I get an error or so, I will say that the error doesn't exist. If not, I will add a role tool. I will get back the tool call ID, which is one of the one of the property, and I will add the result of my function converted to JSON. Then I will add the message no, without any tool call and send it back to the models. So let's do it. It should be enough. I will do CLS. Sorry, CLS. So yes, the UbiNet in the LG Network Pro resource group is paired correctly and the statue is connected, which was what we expected. But what we can see also is the usage. You will see that the usage is very much comparing to last time. Yes, a little urge, but the prompt is much bigger. So you see that you can connect external tools to your models with Foundry CLI and OpenAI API to connect the models to the real world and to uh, uh, ever get contents, create files, or do whatever you want with the model. And that will conclude our demonstration on Foundry Local CLIs with PowerShell. If you want to know, I'm building a module to use the Foundry CLI with PowerShell. The module use the CLI, but can also use the SDK, and you will have all these features inside the modules. Thank you, and thank you for listening to me.